Hello, my name is Jared Skeens and welcome to the Zoom room. Today we want to look at Pure Math 3, Further Algebra, Part 4, Partial Fractions. And in partial fractions, there are 4 categories that we're going to look at. Today we're only going to look at, in this video, 2 of them, simple denominator and repeated factors in the denominator. And then in the next video, we'll look at quadratic factors and improper fractions. So we'll have 2 videos on partial fractions. So what we want to look at today is when we look at a partial fraction, it means that we have a fraction with, in the numerator, there'll be a polynomial with a variable to some exponent. Whatever the highest exponent is in the numerator, that is what you're going to want to keep in mind there, the highest exponent. In the denominator, if your factor is linear, meaning the highest exponent inside the factor is an exponent of 1, then it is considered a simple denominator or a simple factor in the denominator. Here we also have a linear factor with exponent of 1. However, this one is squared on the outside, meaning there are 2 of those factors. So it's said to be repeated. It's the same factor, it is linear, but there are 2 of them. Or we could have a factor with a square on our variable, in which, and the square is inside the factor on the variable, in which case this is considered to be a quadratic factor in the denominator. So these are our different ones, and then there is the improper fraction. The improper fraction is actually going to be the question that you always want to ask first before you get into deciding which of these other types you have. With an improper fraction, you're going to compare the highest exponent in the top with your combined exponent in the denominator. For example, if you look at these, here's an x squared, an x, and an x. So if you were to multiply those together, you have x squared, x cubed, and x to the 4th, meaning the polynomial form of the denominator would have a 4th power on the x. And what you want to do is compare that with the exponent of your highest term in the numerator. And if the numerator exponent is greater than or equal to your exponent in the denominator, then you have an improper fraction and you need to take care of that improper fraction. So, it's just like in basic math. If you have 3 over 4, no problem, it's just a normal fraction. If you have 5 over 4, well, that's an improper fraction because the numerator is bigger than the denominator. So what we're looking at are the exponents. If the exponent on top is less than the exponent on the bottom, it's a normal fraction. But if the exponent on the top is greater than the exponent on the bottom, it's an improper fraction. But unlike basic math, even if the exponents on the top and on the bottom are equal, even if they're equal, it is still considered to be an improper fraction. Okay, so this is what we're looking for to determine if you have an improper fraction, and then after that, then you decide which of these scenarios that you have. Now you might wonder, what exactly are we doing with partial fractions? Well, what we're going to be doing is we're going to be splitting fractions apart. But before we get to that, let's look at what we're used to doing. What we're used to doing is combining fractions and putting them together. All the way through junior high and even first part of high school, you're given two fractions and you're told find the common denominator. So you should be very used to seeing something like 2 over x plus 5 over x minus 2. And to get a common denominator, you see there's an x and an x minus 2. This fraction needs multiplied by x, top and bottom. This fraction needs the x minus 2, so multiply numerator and denominator by x minus 2. So when we do that, we get 2 times x and a negative 4 plus 5x in the numerator, and we have our x and x minus 2 as the common denominator. And then when we simplify it, we have 7x minus 4 over x times x minus 2, and we have we've gotten the common denominator, and we've combined them from two fractions into one fraction. Well, that's all nice and dandy, but sometimes this one fraction is kind of complicated. And if we want to do something with this fraction, now that we're in high school, upper level math, maybe we want to take the derivative of this fraction. Or maybe we want to take the integral of this fraction. Or maybe we want to do something else to this fraction, but the fraction as it is too complicated for us to do that. So what we want to do is we want to split it apart into the fractions like this, because these are then simpler and easier for us to derive or integrate or do something else with. So normally you're used to the forward process. Now you're going to have to get used to the backwards process, splitting the fraction apart. So what you're going to do is you take this fraction and you observe the denominator by what we just discussed over here. If your factors in the denominator are both linear, like this, not repeated, or not quadratic, then this is a simple denominator. And so I'll explain the process a little bit more as we get into the examples, but you need each factor to be represented separately. And you also need to have a variable for these unknown values in the numerator. We know what the denominators should or could be, but we don't know what the numerators are, so we represent them with variables. So we're going to have an a over x plus b over x minus 2. These are our potential fractions that could break off of this more complicated fraction over here. So when we look at this, notice that you have an x on the bottom and the top needs to be less than x because we don't want an improper fraction. So the numerator on top needs to be less than the one on the bottom. So since we have a 1 exponent on the bottom, we can't have any exponent or any x's as a variable in the numerator. So it's just a for a constant. Same thing over here. We have 1 as our exponent, so we can't have any x's in the top. It'll just be a constant. Once we've set it up like this, then we can start to isolate one of these variables. Let's say we want to solve for a. We can multiply everything through by the x to get a by itself. So if we multiply everything by x, we now get, notice over here, the x times x, or the x divided by x cancels, it goes away. So we're left with 7x minus 4 on top, x minus 2 on the bottom, equals the x's cancel, you have just a, plus the x here doesn't cancel anything, so you just get bx over x minus 2. Now, remember you can't divide by 0. You can't divide by 0. So now that we've gotten that x out of there, we've multiplied it and it canceled out here. If our x were to be that value of 0, the very same value that you can't have right here, we now can have over here. So if x is equal to 0 here, if x is equal to 0, and we plug in a 0 in for the x's, we now have -4 over -2 equals a plus, and this is multiply, so this whole fraction cancels out and becomes 0, so that our a now equals -4 divided by -2, which is 2. And notice that is exactly what we started with. Now, if we take our equation here and multiply it by x minus 2 to get this one to cancel out, it also cancels out over here. So we have 7x minus 4 over x equals a times x minus 2 over x plus the x minus 2's cancel, and you're just left with b. Now remember, what makes this, or what can't we have here? Well, x cannot be 2 because you can't divide by 0. Well, now that we've eliminated that from the denominator, we don't have to worry about that. So if x equals 2, over here, 2 times 7 is 14. 14 minus 4 is 10. 2 on the bottom gives us 10 over 2. Here we plug in a 2, it gives us a 0. So all of that cancels out, and we have the b by itself. So we end up b is 10 divided by 2, which is 5. That is also what we have. So then all you have to do is go back, plug our 2 in for the a, 2 over 5, plus plug the 5 in for the b, 5 over x minus 2, and we have went backwards to our starting point. That is what partial fractions is going to do for us. It's going to take a complicated fraction, break it apart into simpler fractions. Now, it's very important that you get these two videos down, because splitting apart the fraction is not the end result. It is the means to the end. So you're going to have 2 questions back to back. The first question is going to have you split the fractions apart. Then after that, which we'll cover in a different video, you'll have a follow-up question. It might be an integration. It might be a binomial expansion. So you're going to take the results from this first part and you're going to do something with it. You're going to apply some other skill to it. So if you happen to get this one wrong, then your wrong answer is going to carry into the next question. And so not only will you lose points on this, you'll also lose points in the follow-up question. So this really isn't too difficult once you understand it, but you really need to get it down and make sure this first part is right so that you're starting with the correct starting point in the next question that might follow it. Okay, so let's get started by setting us up a Cambridge question. Okay, let's look at our first question together. I just let you see the question. Again, maybe you're interested in the code at the top as to what past paper it comes from, or you just want to see what it looks like. I don't have the follow-up, but notice it's part I. So in other words, in the II, you would then apply something else to your result of the partial fractions. So this one's pretty simple here, just 1 over x times 2x plus 3. So let's go back to the board and develop our thinking strategy. As soon as we see this question, we can tell it's partial fractions. We know they want us to split it up. The very first thing that you need to check is for improper fraction. You need to ask that first, even though we're going to cover that in the next video. So you already know, because we're doing simple and repeated, that you're not going to have an improper fraction. You need to get in the habit of asking it. The moment you don't ask that question, you get an improper fraction, and you're going to end up with wrong results, which we'll discuss in the next video. So we want to look, our exponent on top is an understood x to the 0 power. On the bottom, we have a 2x times x, so we have a 2x squared. So in the polynomial form on the bottom, this is going to be an x squared, actually a 2x squared. And on the top, we have an x to the 0. It's an understood 1x to the 0. So we can see that the top is less than the exponent on the bottom. So this is only if it's greater than or equal to. So we don't have an improper fraction. But you need to quickly analyze that first. Now that we've eliminated that as our choice, we need to see which one of these we have. Do we have a quadratic? No, there's no square inside the factor. And we don't have a repeated, we don't have a square outside the factor. So these are just two linear, simple factors in the denominator. So what we want to do now is set up our pattern. We need an x and we need a 2x plus 3. So we need our variables on top. So we'll just be an a and b. Now, if you noticed in the part where I was introducing it, I multiplied both sides by the denominator parts and wrote it all out. It takes a lot of time to do that. These are 5-point questions, and you need to kind of work through it efficiently, and you can save a little bit of time if you do a mental step. Instead of writing out all those variables, you notice I wrote all this part down here, was rewriting the same equation once by multiplying it by x, and the other time by multiplying it by the other factor. Instead of doing that, try to do it mentally. If you need to do that, go ahead, but it takes more time. So mentally say, okay, I want to get rid of this x. So I'm going to multiply this by x. Nothing cancels. It's going to be right there. This one cancels. Only the a is there. And this one will cancel, and I'm left with this part here. Remember the value that you want to plug in. X cannot be 0. But if I've already multiplied it through, it's not a problem. So we're going to say if x equals 0, remember this one is no longer here because we multiplied by x. So we're going to end up with 1 over, and 2 times 0 is 0 plus 3 is 1/3 equals a plus, and remember that x, when we multiply by x, it's right up here. That's a 0 times all of this is gone. So basically a plus 0, or in other words, a is just 1/3. Okay, so we're already got that number there. Now we want to go on to the next part. What if we multiplied everything by 2x plus 3? I'm going to get rid of this part right here. I don't want it to confuse you. If we multiply everything through by 2x plus 3, it's going to cancel, and our b is going to be by itself. 2x plus 3 is going to be up here next to the a. And 2x plus 3 will cancel out this one, and the only thing we have left is 1 over x. So if we solve this one, it's a little bit more complicated because it's a fraction, but it's same concept. Solve this. What will make this 0? You can't divide by 0. Well, it would be a -3/2. So if x equals a -3/2, then that means we're going to get 1 over x, because remember the 2x plus 3 canceled, that's gone. So we only have the x, so we get a -3/2 equals, we have a 2x plus 3 multiplied here. So if we plug in what makes that 0, this all goes away. If you need to see it, remember 2x plus 3, that canceled. 2x plus 3. Again, try to do this mentally, so all that you have is this, and you have 2x plus 3. I got my markers mixed up. And when you plug in a negative 3/2, notice the 2's cancel, and negative 3 plus 3 cancels, gives you 0. And so all of that disappears, right? So all we're left with is the b. And when you divide by a fraction, you invert and multiply. So b is equal to a negative 2/3. So this is your answer part. The 1/3 and negative 2/3 is your answer for the a and b. And if you look it up in the mark schemes, they pretty much just give you the a and b answers. However, I would recommend that you go ahead and write out the full answer. And the reason why is because you're going to have the follow-up question. The question doesn't just stop here. Again, partial fractions is the means to an end. It is not the end itself. In whatever the part I is after this, it's going to take this and continue on with the problem. So you want to just help yourself out. So your a is 1/3, so that means you have a 1/3x. Okay, the 1/3 just means the 3 drops down to here, plus a negative 2/3, or so we have actually minus 2 over, and we have a 3 times 2x plus 3. And so this is how you would write it out. This is your full answer, although the mark scheme is specifically looking for a and b. This is your full answer, and now you're ready to move on from here into whatever the next question might be that follows up with this. So that's our first question, and let me set up for the second one. Okay, let's look quickly at our second question here. It says express 1/4 minus y squared in partial fractions. Wow, this one's only 2 points, so you have to work rather quickly. Maybe there is a shortcut to this one. Usually they are 5 points each, but it says express in partial fractions. So I'm just going to go through it the normal way. I'm not going to take time right now to see if there's a shorter way for that. But when we look at it, here we have 1/4 minus y squared. Now notice there are no parentheses. There's no factors here. In other words, this is in polynomial form, not factored form. So we should split this apart into factors before we split the fraction. And so this would be 1/2 plus y times 2 minus y. Okay, you should recognize that as a difference of squares. You should recognize this was in polynomial form, not factored form. You're looking for factors. So you need it to be factored. And now, again, we're going to start with our improper fraction. We already know there's not any, but you got to ask the question, get that habit established. So here on top, we have a y to the 0. On the bottom, you can see we have a y squared. It's already in polynomial form. The top is less than the bottom, so there's no improper fraction. Okay? So check that first. Now we move on. We see that we have no quadratics in the factors. There's no repeated, there's no exponent outside the factor, and that they are both indeed simple factors in the denominator. So we're going to set this up to be a over 2 plus y plus b over 2 minus y. And again, if we multiply everything by 2 plus y, okay, we're working with this one and this one. If we multiply everything by 2 plus y to get the a by itself, then the 2 plus y will end up here. cancel this, just leaving us with a, and it will cancel this one, just leaving us with this here. So if y equals a -2, because that's what makes this 0, can't divide by 0, but now that we've multiplied it through, it's gone. This is canceled out. Come over, it's ended up over here, 2 plus y. So all of this becomes 0, and we get a equals 1 over, and then when we plug in a -2, we end up with 2 minus a -2, which is 1/4. So a equals 1/4. And then if we say y equals +2, because that's what will cause this to be 0 in the denominator, multiply everything by 2 minus y, cancels out, ends up here, cancels this out, you just have this here. Okay, so we end up with 1 over 4 equals, this is 0, our b. So a equals 1/4 and b equals 1/4. And if you want to write it out as its complete form, you would have 1 over 4 times 2 plus y plus 1 over 4 times 2 minus y. It's a y, not a 4. And this then is your full answer there that you would work with then moving forward into the next part of the question. So maybe because these were quite easy, maybe that's why it's only worth 2 points. But notice for 2 points, if you actually multiply your denominator through and write out all those equations, it's going to take you more time than what those 2 points are worth. So if you can learn to do it mentally, you know, that 2 minus y, okay, 2 minus y is gone. 2 minus y, it's right there. 2 minus y up here, that one is, cancels out this. So what makes that a 0? 2, but it's gone now. It makes all of this 0, because you plug it in there, 2 minus 2 is 0, that's gone. So you have b equals, and you plug in your 2 here, and you just get 1/4. So if you can do it mentally, it goes a lot faster, but just make sure you don't lose something. So it's a little faster than just writing everything out. Okay, so that's this one. Let's move on and see the next question. Okay, here's our next question. Pull it up here real quick. And we see, let f of x equal 7x squared minus 15x plus 8 over 1 minus 2x times a 2 minus x squared. Express f of x in partial fractions. So here we see it's 5 points. See it's partial fractions. We now have a more complicated fraction than what we've had in the previous 2 examples. So let's get to the board and start working our way through our mental questions. First question is it improper fraction? So when we look at the top, we have a polynomial form. The highest exponent is squared, x squared. On the bottom, if we multiply this out, we're going to have an x squared times an x. X squared times x is x cubed. So the top is less than the bottom. So we're okay. It's not an improper fraction. But we always want to train ourselves to look for that first. Not an improper fraction. So if it's not an improper fraction, then what is it? Well, let's look through here. Here, this one is a simple factor in the denominator. But when we get over to this one, there is a square on the outside. That is a repeated factor. So that's going to change our pattern a little bit. For the simple one, it's still just a over 1 minus 2x. Now, when you get to a repeated one, in other words, it's like there are 3 factors here, and 1 minus 2x, a 2 minus x, and another 2 minus x. So what we're looking for is the potential of that 2 minus x, and that 2 minus x might exist as a single factor, or it could exist as the repeated factor. Okay, so we need to, when you have a repeated factor, you need to account for the possibility that it could exist independently as a single factor, or that both of those repeated factors are together. So we're going to end up with 3 variables now that we need to solve. So when we do this, let's take care of the simple one first. This one still follows the same thing as before. So if we multiply everything by 1 minus 2x, it's going to cancel from here. So that's gone. It's going to cancel from here. A will be by itself, and it will end up in the numerator both here and here. Okay? So if x equals, and to solve this, we're going to get a 1/2. You set 1 minus 2x equal to 0, you get 1 equals 2x, x equals 1/2. So that is what would cause this to be 0, and that's what we're going to plug in. So what we're going to get is, we're going to have, this one is gone, so we're going to have a 7 times 1/2 squared minus 15 times 1/2 plus 8 all over, remember this one is gone, so we have a 2 minus 1/2 squared, and this will equal our A, because this canceled out, and because it's up here, and this is the value that causes it to be 0, the B and the C both cancel out. So this is actually what we're working with here, and you can do all of this on your calculator, and when you do that on your calculator, you end up with A equals 1. Okay. Then we move on to B and C. Now we actually run into a little bit of a problem with B, because if we multiply by 2 minus x, yes, it does cancel out here and it leaves the B by itself, which is what we want. It does come up here and will cause this whole thing to become 0 when you plug in the 2. It will cancel one of these and one of those, but it doesn't cancel both, meaning you're still left with a 2 minus x in the denominator. One of them is canceled, one of them is still there, so you can't plug in a 2 because you'll end up with 0 in the denominator. Only one of those factors of 2 minus x cancel out. So because we can't do that with B, we're going to leave it and we're going to solve C first. If we use both factors, it will cancel out. One will cancel out on the bottom and one is left on top. Both are left on top and both of these cancel out. So we're going to skip the B for now and move to C, but still follow the same pattern. So if x equals 2, 2 is what will cause it to be 0. So we're multiplying by a 2 minus x squared. So this is gone. C is what's by itself, because all this is gone. And this one of them is gone on the bottom, but there's one on top, so that all becomes 0 when you plug in the 2. Both of them are on top here. Well, a 0 squared is still 0, so this cancels out. And what we're left with is this over here, and this one, remember, canceled out because we're multiplying by the 2 minus x squared. So we're only left with these and this one here. So our C equals, and we're plugging in a 2. So 7 times 2 squared minus 15 times 2 plus 8 all over 1 minus 2 times 2. And when we solve that on your calculator for C, you're going to get C equals a -2. Okay? So you just run this through your calculator, get C equals -2. For that, now we can go back to the B. So with the b, because we can't use 2, and actually we've already used 2 with the c, what we're going to do is just pick a random number that will make it easy for us to calculate, but we don't get that straight direct answer. Like when we plug this in, a equals, it's direct. Once you plug it in your calculator, that's it. Same thing with this one, it's direct. So we're going to pick a different number, but you won't get a direct answer. You'll actually have an entire equation to work with. So we're going to pick 0. 0 is easy to work with. Pick 0 is my recommendation. But we need to write out the whole equation for this one. So if x is 0, and we've multiplied by 2 minus x, we still do that part. We multiply by 2 minus x to get b by itself. Or you don't have to, either way, just plug in a 0. So if we plug in a 0, we get 0, 0, 8. We just have 8 on top. Over, if we plug in a 0, we have 1. And if we plug in a 0 here, let's just say we don't multiply everything by 2 minus x. Just leave it there because we can't can't plug in a 2 anyway. So we'll just leave it and plug in 0. So if we plug in 0, we get a 2 squared equals, but now we already know a and c. So this is going to make it easier. A is 1. Plug in a 0, just leaves us 1. Plus b over 2, and we plug in a 0, plus, and we know c, so it's a negative 2 minus 2 over, and we plug in a 0, we get 2 squared again. Okay, so notice now we're going to have to multiply by a common denominator. So there's a 4 multiplied by 4. So this 4 will cancel this, giving us 8. 4 times this is 4. 4 times this, the 2 cancels and you get 2b. And 4 times this, the 4's cancel and you get minus 2. So 4 minus 2 is 2. 2 subtracted from 8 is 6. 6 equals 2b. Therefore, b equals 3. Okay, so now we have our ABC. Now we can write 1 over 1 minus 2x plus 3 over 2 minus x minus 2 over 2 minus x squared. This is our long complete form with the a, b, and c values solved. So the a, b, c values will satisfy the Cambridge mark scheme for this part of the question, but you will need to write it out like this so that you can move forward into whatever the follow-up question is for this question type. Okay, so that one was a little bit more work to do. When it's a simple denominator, it's quite easy process. That was for a repeated denominator. Now let's look at one more example. Okay, let's look at our last problem for this video. Here we have let f of x equals 8x squared plus 9x plus 8 over factor of 1 minus x times 2x plus 3 squared. Again, expressed in partial fractions, and it is 5 points. Again, here is the code if you're looking for what past paper it comes from. And let's go back to the board. And again, we want to ask ourselves the starting question as to whether it's an improper fraction or not. And so on the top, we see we have an x squared. On the bottom, we have a 2x squared, so that's 4x squared times a negative x. So we have a negative 4x cubed. It's 4x squared times a negative x. See, the top is less than the bottom, so we don't have an improper fraction. Again, even though we know we don't have that for this video, you still need to ask the question. The moment you don't, you'll end up finding yourself in a bit of trouble. So we ask that question, eliminate that possibility first, and now we look at this, we see here is a simple factor, and this one is a repeated factor. So we're going to set this one up just like we did the last one. And so we have a over 1 minus x plus b over 2x plus 3 plus c over a 2x plus 3 squared. A couple of things to let you know, just in case. First off, it is possible to get a 0 for one of the values of your letters. So if you get a 0, that is possible, just means that that particular possibility doesn't exist for your fraction. And it also doesn't matter the order in which you put these. So I happen to put it into, an order from simple to the more complicated. But if you put them into a different order, maybe your letters might be a different order, but the numbers you get for those particular locations will be the same. So don't worry about the order, and don't worry if you happen to get a 0 for one of your letters, although not very likely, but it's not impossible. Okay, so here we have this, and again, we'll start with the easy one. So if you envision yourself multiplying everything through by 1 minus x, it's up here, doesn't cancel anything out. It's up here, it doesn't cancel anything out. Cancels out so that a is by itself, and it would cancel out this part right here. So if x equals 1, because we want the value that would cause that to be 0, then a will equal, so you plug in, you have your 1 minus x for both of these. You plug in your 1, you get 0, cancels out that one, cancels out that one. So all you have is a, you've canceled out this one, so you end up with 8 times 1 squared, I'll just write that, plus 9 times 1 plus 8, all over 2 plus 3 squared, and you end up with 25 over 25, so a equals 1. Okay, so that's our first answer. Then remember, when you have a repeated one, if you only cancel out one of the factors on the bottom, you can't use that negative 3/2 here. So we're going to move over and do letter C first, and we'll come back to get the B later because we can't use that negative 3/2. You're like, well, since you know you're going to plug in a 0 for the x, why don't you just go ahead and plug in a 0 for the x? I can't do it yet because I haven't found C. We need to find A and C first. That way, when we go to find B, we've taken care of all the other variables. So we're going to skip B, go on to C, and now we're looking at multiplying everything through by the 2x plus 3 squared. So this cancels, leaving C by itself. One of these cancels, leaving the other one in the numerator. Both of them will be in the numerator here, and this one will cancel, just leaving us with this and this. So when we solve this, our 2x plus 3 equals 0. We get 2x equals negative 3, so x equals a negative 3/2. That's the value that we want to put in here. If x equals a negative 3/2, C will equal, because this will cancel out and this will cancel out to 0. So just C equals 8 times a negative 3/2 squared plus 9 times a negative 3/2 plus 8 all over, remember this one canceled out, so we just have 1 minus a negative 3/2. And when we solve this one, we end up with C equaling 5. Okay, so you can do that in your calculator. C should come out to be 5. Now that we have A and C, now we can come back and pick a random value for X in order to get B. The easy one again is 0 because it cancels out a lot of stuff. So if we solve for if X equals 0, and you don't have to multiply the factor through, you can just leave it and make an equation out of it. So if we plug in 0, we get 0, 0, 8. So we have an 8 on top. Plug in a 0 here, we get 1 times 3 squared, so that's 9, equals A, which we know already is 1, over, if we plug in a 0, gives us 1, plus B, we don't know, over, plug in a 0, get 3. And our C is 5, so we have a 5 over, plug in a 0, get 3 squared is 9. So we multiply this all by 9. Cancels out, leaves us 8, 9, 3B plus 5. So don't forget to multiply this one by the 9 because it doesn't count anything out, cancel anything out. This one cancels 3, so that leaves 3B. This one cancels all of it, just leaves the 5. 9 plus 5 is 14. Subtract 14 from 8 gives us a negative 6. So B equals a negative 2. So now that we have our 3 values, we can write out the whole thing. A is a 1. This is the full answer. B is a minus 2. And C is a 5. And so now you have the full answer ready to go for whatever that follow-up question will be. And by the way, you're probably wondering, when am I going to see that follow-up question? Well, the next video covers quadratic and improper fraction, but then the video after that will be one of the follow-up applications that will take this and then go ahead further with what Cambridge wants you to do with it. So remember, this is a means to the end question, and later you'll have the follow-up application that will take you to the end result. So this is how we do simple and repeated partial fractions. And again, thank you for joining me. I hope you're able to follow that mental part. Saves some time from rewriting every time all those variables. And you only have 5, it's 5 points. So you have 7 minutes, but if you can trim some of that time by doing mental things, then it can save you that precious time for other questions that might be a little bit trickier to solve. So again, thank you, and hope to see you again next time.